The purpose of this lab is to determine the specific heat capacity of a metal, and based on that specific heat capacity, identify what it is made out of based on that one property. You will use page 314 in your book, which has a specific heat capacity table that will identify what substance your block must be made of based on the value of the specific heat capacity you got. In order to do this lab, we'll be getting a cube of an unknown metal that you don't know what it's made out of, a calorimeter, which is made up of 2 coffee cups stuck together, and a cardboard cover that will go over the top, a thermometer, and a beaker to boil the water. We will start the lab by boiling water and using a Bunsen burner and getting it so that steam is rising off. Once that is happening, we will take our metal cube and we will immerse it in that hot boiling water. We will let it sit there for 6 minutes, and after 6 minutes we will assume that the temperature of the water and the temperature of the metal cube are the same. After sitting there, heat will transfer from the hot water to the cold cube, and they will reach an equilibrium temperature. So after 6 minutes, we will take the temperature of the water, and you will assume the block to be the same temperature. We will also get a calorimeter and put cold water in there. The cold water in the calorimeter must be 100 milliliters, because if we know it's 100 milliliters, we know the density of water is 1 gram for every milliliter of water. If I have 100 milliliters of water, then I must have a mass of 100 grams. And so it's very important to measure that out exactly, 100 milliliters, and have that ready. Then, before we start the whole thing, we had to get the mass of the block, and the mass of the block for you was block 87.8 grams. So we take that block, we immerse it in hot water, we let it sit for 6 minutes, and it reaches a temperature of the hot water, and therefore temperature of the cube to start this experiment is 98.5 degrees Celsius. We take that hot block then out of the boiling water and transfer it as quickly as we can to the styrofoam cups of cold water. We transfer it quickly so that we don't lose too much heat to the air, and then we cover the styrofoam cups with our cardboard cover. Now heat starts to transfer from hot to cold, hot to cold, hot to cold, and heat keeps transferring from the hot block to the cold water. The temperature then in the cold water to start was 22.7 degrees Celsius, but when that block is transferred, that temperature goes up. It keeps going up because the hot block is giving heat to the cold water. It'll keep going up until it reaches its maximum temperature. At that temperature, we assume that the block and the water are the same temperature. They've reached a new equilibrium. Eventually, that temperature will start falling back down, and it starts falling back down when heat starts escaping out of our system. So we want to write the highest temperature of the 2 cold water and hot block when they are together. They reach the same temperature, and that highest equilibrium temperature reached was 35.1 degrees Celsius plus or minus 0.1. Oopsie. Degrees Celsius. This should also be plus or minus 0.1 degrees Celsius. This is plus or minus 0.1 grams. And I forgot all those. 0.1 degrees Celsius. With this information, you should be able to determine what the specific heat capacity of the block is, and then therefore what the identity of the block is using the specific heat capacity table, and then complete the rest of the lab.